Mario Sanoguera de Lorenzo, and today I want to give a meaningful introduction to app modularization. First of all, let's start by fixing that whole picture with a new one. I'm the guy with the Turo t-shirt, and for those who don't know, Turo is basically the company I'm working on right now, and it's an Airbnb, but for cars, where users can just either be hosts and lease their own cars, or they can be guests and book cars from other people, like for a classic weekend trip. So a bit of background why I picked this topic, like app modularization. I wrote some articles back in 2018 about architecture and view models, presenters, all these things. But when I started talking about writing and discovering the different ways of modularization, I was really fascinated on the different ways you can actually modularize an app. And there's no real right or wrong answer. You just need to be aware of the different advantages and disadvantages of every approach. I also like the fact that once you have a modularized project, it kind of opens the door to questions like, should I have different architectures depending on the feature that I'm working in, or can I create some launcher modules to make to easier test my own features and so on. So let's start with the first question, which is, what is modularization? If we search online, we can get a definition along the lines of a software design technique where we separate functionality into independent interchangeable modules, and so that each contains everything necessary to execute a specific functionality. So this is for me, it's one of the most important slides because it's something when you're modularizing, you have to remember what is modularization and what is the goal of modularizing an app, or your whole monolith if you're in that scenario. You can always think of as modules as different unique pieces of Lego where you can stick them together in multiple possible ways. So now that we know that what modularization is, let's jump ahead and check what are the most common module types on Android. Most of you will already be familiar with these ones, but starting with the app or the application module, you can identify this one by having, because it has the apply plugin of COM Android application. It's the main module of your application, and you can only have one per installed application. And if you just create an Android Studio project and you click run, you're running this module. The output is normally, so yeah, at least the main model of your application. It will output, when you click play, it will output an APK. It can also output an AAB, which is an Android app bundle. I won't be explaining today, but lastly, the fact that you can only run one application at a time doesn't mean that you can't have more than one app in one repository. So there's a very interesting it's a very interesting concept, which is commonly called demo apps or single feature apps, and it's already being used and adopted by some Android engineering teams around the globe. I will be explaining later on with a better example, but basically it allows you to reduce your clean and rebuild times to something under 20 seconds, no matter how big your project is. Next, we have the Android library. This is the most common one when you're building features on the app, since most of them depend on the Android framework on the edges of your architecture. So for example, if you have to show an activity, you need an Android library. If you have a module which depends on cache, it depends on, in the end, you need some kind of context on the line, so it will also be, you will also require to have an Android library there. When you build an Android library, a standalone Android library, it will output an AR file, and the AR file can contain Android resources and also a manifest file. So whenever you're including some libraries into your project and it's not a module that you control, always make sure to check your manifest, your merge manifest, because you can find some surprises there, like, oh, why do I have this permission, and all of these things. You can always override it from application if it doesn't break the existing library, but just to be aware that when you introduce a library as a dependency, you will always have these merge manifest resources and all of these things. To end with, we have the kotlin one. I was going to talk about Java, but it's kind of dying right now. Due to kotlin high adoption and interoperability, the Java library is less of an option, but it is always good to think who will be consuming your library. So maybe you don't want to have the overhead count of adding kotlin to your project or some things like this. It has no Android dependencies, so that's the main feature of the kotlin library. It will create a jar file, and it's suitable for domain logic or just libraries that don't really depend on the Android framework at all. Like, there's no reason to have an Android library because that will have some Gradle overhead where you have some tasks that you don't really need them. So yeah, like now that we covered those two, let's imagine a simple scenario where we have two Android libraries in our code base. And we have module A and module B, like for simplicity. And module A needs to execute some code from module B, so it will just depend on module B. At some point down the line, due to product requirements, module B will require to execute some code from module A. As soon as you try to do this and you click on the sync on the Android Studio, you will get an error message indicating you have a circular dependency. Even if this can block, if this can block our work, this is actually a really good thing that our build system is telling us, hey, wait over there, like you can't have a circular dependency because I don't know which one is first, right? And it really helps if you have a monolith, like from my experience, if you have a monolith and you start like modularizing, you can end up discovering hidden circular dependencies that you didn't know they were there because everyone has access to everything in a unique module. So it's kind of like a good way to understand where your dependencies are. There's this is like more a subjective opinion, like you can resolve these kind of dependencies with like any cyclic dependency by using interfaces. But I would always advise rethinking your design. Why do I have this scenario? Why I'm running into this scenario? In some cases, it might be the solution, but always stop and think what you should do next. Like if there's a way to just pull this dependency down, make two modules depend on that module, and so on. So there's many reasons why we should modularize our projects. Let's start explaining one for me, the most important one, which impacts a lot in developer happiness. Improving rebuild times. If you're using Gradle as a build system, you will have to enable something on Gradle properties. It's like this flag over there on caching. And this Gradle, like we have to understand how Gradle works and that each module has its own, like the Gradle build cache works on a per task basis. This means that there's one compiled task per module. So if you have one module with all of your source code, like a monolith, and you're changing some source code and you click play, it will always rebuild that module, right? And in that case, even if we have caching enabled, we won't be making any use of it. So if we start having more modules, we will start getting some benefits from these rebuild times. Basically, if we have 10 modules and we're working on one of them, when quick rebuild, Gradle will already have the cache saved from the other modules, and it will just pull it from cache, saving us a lot of time. I got some numbers from Turo, and right now we're in the process of modularization, and if you try to change something on the monolith, which we call legacy to avoid people wanting to work with it, you will run into a situation where you're waiting like 4 to 5 minutes. If we already started like modularizing by feature, if you're changing some code in a modularized feature, we can see how the build time just drops from 4 or 5 minutes to like 1 minute, depending on how big the feature module is. And in the end, I will explain the demo project, but like if you run into the situation of the demo project, it's just like 15 seconds straight. I was talking, like going next, this is also into the Gradle properties file. So we want to enable the parallelism flag. This specifically helps with clean build times. And again, like remember, there's only one compiled task per module. So if we move from one module to multiple decoupled modules and we have a clean build, we can enable parallelism. And this means that we can make use of the power of our machines by having multiple cores, by using the multiple cores. If you click play, you can see how Gradle is doing like multiple tasks at the same time. So as soon as you enable it, you will be able to see it. For this, as an example, I remembered a talk from Airbnb that I highly recommend. And he did some cool project where he did like a very cool project where he was testing, like just creating a project with lots of source files and making clean builds, like so on, so on. So if you can see up here, if you have one module with parallelism enabled, you can't build anything on parallel. So the build time, the clean build time will always go up and up. As soon as you start including more modules, you can see how no matter if the source files, I mean, obviously if you add more source files, the clean build time will increase, but it's diminishing. So the more you're able to save a lot of time. And here it goes from 175 seconds to around like around 50 seconds, which is pretty good. So the larger your monolith is, the more time will be saved on clean builds once you start modularizing. So now that we cover the faster build times, which I think is one of the most important ones, I want to go over some other reasons why we should modularize. Improves reusability means that new modules won't need to depend on your monolith just to use a specific functionality. And having a top-level module also helps giving more visibility to what this is. You can also think about adding some readmes, explain like this module, what is the purpose of this module, who is the owner, it's kind of like because you're just surfacing the module to the top, you will be able to give more visibility into it. It's a bit subjective, but it's kind of like, this is one of the things we're seeing right now at Turo. For fine-grained dependency control, it can clearly be seen with an example. So let's imagine we just have like a large app with a unique or a few modules, and we visit our build.gradle file. We will see something like this. And this is clearly like a dependency overflow because we only have one build.gradle file defining all of the dependencies that we're using. But even if we like zoom in into a few dependencies, we can suddenly start asking questions like, which features of my app require any maps? Like, which feature has some nice Lottie animations? What about Card.io or Stripe? Like, this looks like it's just like a payments dependency. Why all of my app has access to, all of my module classes have access to these two things? And this kind of, the fact that we have more fine-grained dependency control, if we don't have it, it goes against like the definition that I was explaining at the beginning, which is everything necessary to execute a specific functionality. So if we're working in payments, why should we have maps? We're adding a dependency extra that we don't really need. Some other of the reasons, like I have to skip because I want to go into the how, which is the most interesting one. Ownership and quality of the code base. We can use code owners for this. Basically, code owners, for those who you don't know, you can just add a file and GitHub will automatically assign you into RPR if someone is touching code in your module. It can encourage, this is kind of subjective as well, but it can encourage, if you're building a module from scratch, you might stop and think like, oh, let's create it in a like reusable and agnostic way. And if you try to modularize this in the future, then it will involve as much effort as if it was in the monolith. This one is pretty good. That the stricter boundaries can help to avoid mistakes. So most of the times, you don't want to expose many things outside of the feature modules where you're working in. In those scenarios, Kotlin has a really cool visibility modifier, which is called internal, which is specifically made for this. So it allows you to have like small modules where everyone can know about each other, but as soon as, even if I implement this module, I won't have access to these things because they have the internal visibility modifier on front. And to end with, and not less important, for some things, we just need modules, like instant apps or dynamic features. Dynamic features are basically modules that aren't shipped with the app when the user installs, but instead it's downloaded at runtime when required thanks to the play core dependencies. And this helps, like dynamic features helps reducing app download size, which has been proven to increase installs. Like the smaller the app, the less chance people will just cancel because your app is 100 megabytes, for example. So when should we modularize? It is like super subjective. When it makes sense, but always remembering what is modularization and the different reasons why we should modularize our project. You have to also consider different factors like what is your project size, your build time, do you have many dependencies in your single module, or do you work in a large team? There's lots of factors you have to consider. One of the most important things, which is not really related to development, is communication. You really need to communicate to the stakeholders of their company. What is the value of modularizing? Why you want to modularize your project? It might not have a direct impact to the user because you're not building a new feature, but down the line it can have an indirect, it will actually have an indirect impact to the user, in the sense that because developers are able to iterate faster through the code base and compile faster, they will save more time, they will spend less time navigating through the flows. Like all of these things will increase developer happiness and will increase productivity like pretty fast. One of the things I learned the hard way is that when you're modularizing, it's essential that you don't do the heavy lifting first. You can always think as if you were to modularize your current app, you should never start modularizing the most important part of your app because it's probably the biggest one and because it probably has the most dependencies of all. So if you're familiar a bit with clean architecture and the onion, you kind of have to think of modularizing the easiest things first. So what is something that is it probably shouldn't have many dependencies, if not any, like a retrofit. Like our network modules should be fairly easy to modularize, right? We only have OKCP, retrofit, and we're creating an instance there, and that's it. So that's kind of like trying to approach through the onion. At some point, you will have to modularize the hard part. But if you try to modularize the easy part first, when you go to the hard part, you will have less dependencies to deal with because the outer dependencies will already be modularized. And yeah, like another example could be cache, for example. If you're using like an OSQL, you could modularize cache, or maybe you should, like if you want to modularize a feature, we at Turo decided to modularize like a very simple feature. Like the most simple one is just basically completely agnostic. You just need to send some parameters, and it will do the rest on its own. Before jumping into how we should modularize with a small example, I want to mention that as soon as you modularize your app, you will have multiple build.gradle files, like one per module. And without any Gradle dependency management, it will be far from ideal and quite error-prone. This is basically because you will end up, like, if you end up copy-pasting the same dependency in different places, like hard-coding it, if you want to update the version, you will have to go through all of the build.gradles. You want to have a unified place where you can just have all of your dependencies and you can control them. So for this, Google is still recommending using like Gradle and the X approach, but now with Android Studio 4, they actually remove build source as experimental. And basically, build source is a Gradle module where you can write Kotlin code like usual with like full tooling support. And the code is then available to all of your build files. Both IntelliJ IDEA and Android Studio have good support for calling it from any build.gradle. And to make use of the build source, we just need to create a build source directory like you're seeing here. And inside the build.gradle, we just need to enable the Kotlin DSL. That's it. We can sync, and after we can sync, we can start adding our own dependencies. As you can see, it can be useful for dependencies, but it can also be useful for releases, for modules, for mean SDK version, all of these things. You can just have it. Like you can do it however you want it. It doesn't need to be in one single file. Build.gradle, like build source, becomes even more convenient when we learn how to write custom Gradle tasks in Kotlin because we already know Kotlin and we're already familiar with it. So how should we modularize our project? Let's cover most of the common approaches I've seen, and there's no right or wrong answer, but I want to kind of explain what is the advantages and disadvantages I saw from each one. So before that, let's just picture a pretty simple app. We have very common features in many apps like Splash, login, payments, and setting screens. We also have some feature flags that are fetched. Let's say they are fetched during the splash screen, some kind of user management, and our app probably also makes API calls to different services. So we have like a network module. So we have a network module that provides our OGP client and the retrofit object. We also save data into this, so we'll also have like a cache module. And to end with, we have common view components, like this something a year ago started like happening, like design language library. So we'll also have like a views module. As you can see, there's modules can depend on each other because of the circular dependency. But furthermore, I think it's a good rule to have that a feature should never depend on another feature. The main reason is that down the line, one of the features need to depend back on the other feature. And because of the circular dependency I was explaining before, you won't be able to do it. So we should always think of features as small standalone apps that only have what is required. This is like a really, really important thing. For navigation between features, I will explain a bit later on. So let's focus what happens when we have a shared code between two features. In this scenario, I just picked like payments and login. And let's imagine we just have some sort of A/B test that shows different screens for both features. And you need to ask the server at some point which test group they are in. So in that case, we don't want to duplicate code both in payments and in login. What we want to do is extract that shared logic down into our feature flag module. This feature flag module will need to talk to the server, so it's completely fine that it depends in network. So basically, when it comes to libraries, it's fine to add a one-way dependency when it makes sense. You always have to think as shared modules versus common modules. So a shared module would be something that is only used by a set of features, and a common module would be something that most of the apps needs. Like, for example, network or cache would be a base, like network, cache, or analytics would be like a common module, and feature flags would be a good example of a shared module. So starting, like, this is when I started investigating about modularization and I was learning about it, I saw many examples and many GitHub projects which had this kind of approach. But it is something you don't really want to do. Like, the reasons is that if we just modularize by layer, we'll end up having a module distribution like this one, and there is no separation at all between the features. So it's really easy to couple the code or create hidden circular dependencies inside the different layers. With this approach, the number of modules that you have is also too low, and you are limiting and not taking full advantage of caching that I explained before, and also of parallelism from Gradle. So this means that every time you change code in any of these layers, you need to recompile the whole module. Furthermore, we have to think how, like, most of us, I guess, will be like product developers. And whenever we're working in our feature, we don't really work. Sometimes they will require some changes on the view layer, but in some scenarios, they will be like, hey, can you add this extra field? It comes from the backend. I will have to touch like the whole 3 layers. So in that scenario, it's even worse because like I will have to change data, domain, and presentation. And when I click compile, all of the modules none of the modules will come from cache. So we'll be losing that efficiency that we all want to have. So let's check how modularizing by feature actually looks like. We have our app at the top as always, and we will be creating like different modules, like different features. So let's imagine again we have splash, logging, payments, settings, and some future feature that we will have in the future. And we also have like our libraries, right? Like network, which is a common module, cache is also a common module, views, and then we have user manager and some like future lib. So how do you really, we also have navigation, which I'm explaining a bit later. But one of the common mistakes that I've seen is that people like to add a base module. It sounds really good and it kind of makes sense, but the biggest mistake of base module or base or core module is the name. It doesn't provide any meaning to what base should or should not contain. And if I'm a feature developer and I'm working in, let's say I need something that is being used in Splash, login, and payments, the easiest thing to do is just pull it down to base. So if you extrapolate this into 50 modules or 50 features, you can see how base is going to grow and grow and grow. And probably you're just using a couple of things from base, but because many developers are adding things to base, it will end up being like a second monolith in our app. So we want to avoid that at all costs. Instead, like, think what is the shared code you're going to modularize and give it a proper name. Like, naming is hard, really, really hard. Like in this example, we have the user manager as or the feature flags that I was showing before. Another easy mistake to do when modularizing is having a module for shared use cases or for shared data. If you remember the first approach, which is like modularized by layer, it's kind of like you're mixing modularizing by feature, but at the same time, you're using some modules that are just layers. And it's really easy to say, oh, 3 features need to use the same use case or need to get some it needs to get the same data from the same place. So I will just put it on common data. Again, the problem here is the common data, which is allowing the module to be very big and developers to actually just dump all the things that are shared instead of like, oh, I have to think about the name and create a new module, or maybe there's an existing module. It's way easier to just say like, oh, common data, I will just put it there. Next, modularizing by feature and by layer. I actually did this mistake we did this mistake in our previous company. But basically, if you're already with like different architectures, like clean architecture, you will, when you're modularizing, you might be like, oh, like modularizing by feature and layer sounds like a good idea. You're modularizing way more. In my experience, this takes modularization a step too far, and there's no real benefit to it. Instead, it brings some drawbacks. The main drawback of this approach is that you might run into situations when there's two features that need to execute the same code. In that scenario, people will just add a dependency between, let's say, settings domain to payments domain. If you escalate again this into a big project, you end up with like a dependency hell, and you don't really know, like, oh, why is settings depending on payments? Like, there's no real explanation behind it. So it's kind of like it will make your dependency graph way more complex to understand. So again, we need to remember that in most cases, you will be owning and working on an entire feature, just not just a layer. So this kind of approach doesn't really bring lots of value. Like it's pretty subjective. I've tried it, it didn't work. It might work under some specific use case, or if you're building an SDK or something like that. But for most feature development, like for most of the common apps, this is just an overhead that will end up in a more complex dependency graph. So again, let's go back to the feature modules and how do we navigate between feature modules, right? Because like from Splash, I probably want to go to login, and then after I'm in home screen, I will probably want to go to payments or to settings. How can we navigate between these two? There's different approaches, and the simpler answer that I found, and I found like also thanks to Airbnb last year, is feature modules like navigation through reflection. It sounds really bad. I adopted this approach around like a year ago. We were using it at Turo, and we're not seeing any issues with it right now. And although it sounds bad, it's easy to read and to unit test. You basically write a test comparing the string, because basically we're creating intents where you pass a whole canonical name as a string, and you can just write a unit test where you compare the actual canonical name of the class with the string that you have in navigation. And if it fails, you know that if you refactor the actual class, it will fail, and the unit test will tell you. Probably you will want a parameterized test in this case, and if you have someone in your company which is familiar with bash files, you can just write a script as well that will do it for you. Navigation is one of the most shared modules, right? Because we will have many features in our app. We modularize by feature, and we want to make sure that we add no dependencies, and we just keep the navigation module with the intents, that is something from Android, and the primitive types. So always try to avoid sending one domain object from feature A to feature B, because this will involve that there's a direct dependency between both. To end with, kind of, you have the demo apps that I was talking before. So if you have like a feature modularized approach, like the one you can see here, let's imagine we're just working on the payment feature. In that scenario, I don't even want to index or compile at all of the other feature modules that I'm using, and the shared modules or common modules that payments is not making use of. So in this scenario, it would be like, I will just create, because we have, if you remember at the beginning of the talk, you can have multiple applications. You will create a small application, like you can call it demo app. This demo app will depend on payments, and payments will depend on network and probably in views. So after I click run, I will be only working with a small set of files. This will enable, like, I can just click run, and everything will compile fast. In order to take advantage of this fast compilation even further, you can make use of something called load and load modules. So if you double click on Android Studio, there's an option, and also IntelliJ, so this comes from IntelliJ. You can select like load and load modules, and loading modules makes the IDE way faster. It doesn't even need to index those modules because it will just ignore them. It also avoids Gradle from compiling the other modules, and in the end, you end up saving a big amount of time. So kind of like some of the tips and learnings that I learned through this journey of modularization: always communicate with stakeholders. Always profile your builds. Like, you might think you're doing something which is improving the build time, but it might actually not. If you don't profile it, you have no real measurement of if you're making a mistake or not. Maybe it's a small mistake. Maybe it's something that is only adding 15, 20 seconds, or that's a lot actually, but like 5, 10 seconds. But the bigger your team is, and the more people are working in the same project, this number can just escalate really, really fast after like a couple of months. Avoid base modules. Like, always try to give a good naming to your modules. This can help other developers. Like, it can help other developers understand what the module actually is doing and what you're expecting from it. Implementation versus API. I didn't have time to explain this one, but basically, you always want, in most cases, you want to use implementation. Basically, it avoids, if you just search on implementation versus API on Google, there's like a really good medium about it. But it basically explains how if you use API, you are exposing the dependencies that the module has, and it will also affect the build time, because Gradle has to make work more around, okay, because it's using API, and needs to expose everything behind it. Document modules with readmes. Again, you have to be a bit careful you have to be careful with this, because the more documentation you write, the more maintainability it requires. So we always want to try and give just an overall sense of what the module is. The module, probably if it's a feature, it doesn't really need documentation. But if it's like a shared module or a common module, for example, analytics. So how should we use the analytics module? Let's write a unit test, let's write an example. So just like pointing to a few examples, and that's it. Like, the code can change and the documentation should be updated. So just be aware that the more documentation you write, the more documentation you will have to update. To end with, and it's also really, really important, clean up and use dependencies and also update them. Something I forgot to mention was that was around KFT. So if you know, the KFT is called in Android processor tool. And if you're using Dagger, and you haven't updated Dagger in a while, you won't be making use of incremental KFT. This is a very similar concept to caching. Basically, when you add an annotation for Dagger or a singleton, it will create your code. Like, it will generate some code behind the scenes. And if it's incremental, if you have updated Dagger to the latest version, it will have incremental enabled. And when you click run again, it can check, like, okay, the source file hasn't changed. Then I'm not going to waste time generating the code again. So it's kind of like a huge time saver. One thing that, at least right now, it's like this, is that if you have, let's say, multiple KFTs in your project, in a single module, let's say like Glide and Dagger, but then you have something like, which they are incremental already because we updated the dependencies. If you have a dependency like epoxy, which is not incremental yet, then having one non-incremental KFT will break incremental for the whole module. So this is something you always have to consider when adding dependencies. Like, is this code generation really useful? Is it saving time? If yes, is it worth, like, it's just like a trade. Like, is it worth the time that it's going to add to KFT versus the time that it's going to save for me? That's pretty much it. Thank you.